All right, so hopefully this is going to be a pretty quick lesson for those people following along. Um, this is something we've done already, and now I'm just going to reiterate what we're doing. And the homework problems for today was supposed to be, I believe it's 37 through 45. So yeah. Anyway, so class. Oh wow. Kissnet. Yeah. Okay. All right. This same thing that we have been doing when we take the integration, it's always going to be top minus the bottom. So we integrate and then we take the top minus the bottom. So if in a definite integral, anyone know what I'm missing here in a definite integral? Yep, perfect. C. There's no C in a definite integral.
Okay, so you only find the derivative of the thing if it's not x. So like b was like 2x.
Oh, yeah. No, I know what you're saying now. No, for yesterday's thing, right? Okay. So when we actually had something different, the integral canceled out the derivative, except when what I'm plugging in, when I take the derivative of that, it's a chain rule because it's the derivative times u prime or whatever we did for the sub. So that's the only thing different when we have those is times u prime.
Okay.
Okay. All right. So first one right here. For A, fundamental theory of calculus, we're just trying to find this out. So I have x squared. So what is integration of x squared?
X cubed over 2.
Yeah. From -2 to 1. Top minus bottom, so it's going to be 1/3 minus
1/3? 1/2? Oh no, yeah.
minus, okay, -2 to the third over 3. So that's going to be a -8/3. So it becomes +8/3
So that's 3.
and 9/3, which gives me 3. I almost heard what you said.
Isn't the fundamental theorem of calculus when you reverse it?
When you what?
No. When you put the negative in front, and then switch the.
Top minus bottom. That's the part that we're doing. We're doing top minus bottom.
Okay. Wait, so what is the fundamental theorem of calculus?
There's 3 of them. The one that we dealt with yesterday, this is part 2.
Okay.
This is part 1. When we're evaluating it, we're taking the derivative of the integration. All right, next one. What is the integration of cosine? Sine. So I'm going to have sine of x from 0 pi over 6 sine of pi over 6 minus sine at 0 You guys remember what that one is?
Like arc cannon with that?
Not tan.
Or so set?
Hmm? Yeah. So that one's going to be arc sine of x from 0 to square root of 3 over 2. All right, top minus bottom. So where on the unit circle is sine square root of 3 over 2? Pi over 3. Where on my circle is sine equal to 0?
0?
Yep.
And then what's sine's domain?
Sine's domain is from negative pi over 2 to pi over 2. All right, this one right here.
Like ln.
Mm-hmm. Because if we rewrite this and we use the rules, this is what I'll show you right here to remind you about this. X to the negative 1, right? And with integration, I always add 1 and then divide by that. If I add 1, that would give me x to the 0 over 0, right?
Yeah.
So that right there should tell you that that is different. So if you have trouble actually remembering which one's ln, hopefully that will help you. All right, so I'm going to have ln from 1 to 2. And I can just plug it in. So it's ln of 2 minus ln of 1. And one of those things is something that I should know. ln 1 is 0. ln 1 is 0. So it's just going to give me ln of 2.
This was also part of the homework A, too.
Yeah.
Yeah.
But this is stuff that we did back in 5.1, I think.
Yeah.
Or 5.2. We've already done this, but this is actually specifically called the fundamental theory of calculus.
Which is just solving it, right?
Yeah.
Would we have to remember the trig function for derivatives?
Yeah. So the arcs are important, especially trying to identify that versus trying to do the math on that one. That one's not going to work out like you would think. Okay. All right. So next one. Give me 1 second. Joseph, grab your stuff. I got someone knocking on my back door.
Really, how did I take 3 times? I got his drinks before me. But it's like, yeah. 2 drinks for me. By the way, they're hella fake there, bro.
All right. So find the area of the graph from here to here, from this to this. Now, we've done areas so far by what's the word they specifically use for this? Because you're going to have homework problems like this. Hello? Yes, it is. Give me a second. Okay, so the word that they're using right here is accumulation. Accumulation function means that we're adding all the parts together under that curve. You can just leave it there. So for this one right here, we're going to do the integration. So let's write the interval. So the integral of e to the x dx, and I'm starting this where? From -1 to 1. Now, what's the derivative of e to the x? What's the antiderivative of e to the x? Yeah. So this is basically saying that I'm going to have e to the x from -1 to 1. So mathematically, I'm going to have e to the first minus e to the -1. Yeah, it's 1 over e, so it's e to the first minus 1 over e, like that, and this comes out to be like about 2, I think, because e to the first is like 2.7, blah, blah, blah.
It's E, right?
Yeah, that's e. E is a number.
So we just leave it as.
Yes, leave it as that.
What is E? Like, we know pi is, what is E? Like,
2.7, blah, blah, blah,
so
blah.
like, what is it?
It goes along with natural log. Okay, these things are numbers in which that exist in nature and appear. So I'm in the thought that math is something that is discovered, not created. Pi was discovered. It's something in nature. It's a pattern. It's something that keeps popping up over and over and over again. It is a numerical constant for a lot of what we have. So right here, E is another one of those. We have another one which is like tau, which you don't use much for anything unless you're like super high-end type stuff. Yeah. So that's like physics stuff, but that's calculus-based physics if you were wondering about that. So if you want to get like mind bending, Google or put ChatGPT and say, hey, how do you get E? How is E a number? And so, yeah, they'll take you down a rabbit hole. All right, so then it's going to be, so right here, E to the first, which is going to give me my 2.77, blah, 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 minus E to the -1. Hit Control, Enter. There we go. Uh, 2.35. And once you actually get into the 40s for the homework, the accumulation function, it's the same thing with doing like the rectangles that we did. Make sense? Okay. All right, there we go. Make sure you all like, share, and subscribe.